in that way, I kind of like it. It's going to be very personal. Did I lose my screen?
Still good.
Okay, good. Yeah. If you have any questions throughout the talk, if you kind of want to chime in or kind of go down a rabbit hole, just kind of unmute yourself and kind of ask questions straight away. I don't mind being asked questions during when I talk, so definitely do that. I want to make sure it's as valuable for you as possible. I think this is the group that probably has the most background in this area and like knowledge that I ever presented to. So it's going to be interesting to give you this talk and see kind of what your reactions are and if there's any takeaways that you can have as well that would be useful. So, but a bit about me myself first. I think as people may already know on the chat, I work for Excella. We are a tech company based out of Arlington, and I think this meetup is usually hosted there actually. So that's great. I hope you get back there one day once the office reopens again, which hopefully won't be in 2 years. So we'll see. But I'm a Microsoft MVP as well. I love contributing to the community in general. I'm mostly focused towards Microsoft technology stack and mostly focused towards .NET and software development. That's kind of where my home base is. But on the side, I do love machine learning and growing into the community. And my niche and my focus is mostly on the machine learning in .NET community, the ML.NET community. And I founded a conference together with Microsoft and some other community members that we have twice a year. It's called the Virtual ML.NET Conference. And I think we'll have one in April as well. So if you kind of want to tune in to hear more about what's going on there, definitely do that. One of the things I kind of really picked up early, because there's a lack of that in the .NET community, is MLOps. So I have written my own open source project for MLOps that supports that kind of process, and it's called MLOps.net. And if you have time today, I'll show you an example just to give you an idea. But the basic theory and kind of the structure and the process is the same for that tool as it is using any other tool that you'll have in the market today for the more Python-based or R-based machine learning communities. If anything I say today sounds fun, if you want to learn more, or if you have any apps on your companies that you want to kind of get assessed on how to kind of bring more MLOps feel into them, definitely just send me an email or kind of reach out to me on Twitter, and I'll be happy to have a look at them for you as well to give you an idea of like how your transformation journey may or may not look. So, or if you just want to connect, you can connect with me too. I would love more friends. So we're here to talk about MLOps today, and I'm going to try to make a distinction between MLOps and DataOps as well, since this meetup is more focused on DataOps in general. But as you are definitely more aware of that than anyone else, MLOps, ML and DevOps can marry very nicely together. And there's this huge need for it as well to kind of automate the life cycle of a machine learning algorithm from kind of idea phase all the way to production and back again. Just as you have that kind of same structure around the data as well, making sure you know where it comes from and how it's funneled into something that can be used. If you want to read more after my talk today and get some more kind of meat on the bones, there's a couple of resources I recommend. The Martin Fowler article, CD for ML, so continuous delivery for machine learning, is one of my favorites. It's a great article by Martin Fowler from ThoughtWorks, and he really goes into detail some of these fundamental principles that you have to look out for. So definitely look at that one regardless. Google has also a couple of research papers around this, and they don't really mention MLOps per se in their titles. But if you look at things like hidden technical depth in machine learning systems and so forth, you'll find papers kind of talking about both the DataOps sides as well as the MLOps side of maintaining an intelligent application of sorts. Super good information there as well. And since I focus on Microsoft, I also want to throw in some Microsoft resources. They also have, of course, have some cool products we'll look at later, and there's some good documentation there on like how they view MLOps and how they want you to implement that. So to start off things here, I am personally a big Star Trek fan. My wife is as well, and we have just watched all of Star Trek Discovery together. But I want to use Commander Data here as our data scientist, just to give you a brief example of like how a general exploratory machine learning process would look like for someone today. And you are more than aware of these things, I think, already. So I will be very brief on this, but I want to give you like a baseline and where we're trying to work from, right? So basically, of course, if we're building a machine learning model, in many ways, some of the fundamental steps we're looking at here is like a data prep area where you're all experts, the model training part and the model evaluation part. And then some point down the line here, we throw it over the fence and we deploy it to production so we can consume it through web service or incorporate it in an app in some way. So if you look at the data scientist's perspective here, the first part someone may do is, of course, look at the data, where it is, how to clean it, offline sources, mend it together in some sort. In many times, especially if you haven't implemented good data practices, as you, again, are aware of, you may have that data on a drive somewhere, like a shared drive. It may be a CSV file. It may be a CSV file multiple people have access to, and they may just change columns, names, values. They may have new calculated values for their own things. And the same data source may be used for multiple different models, but they may be altered throughout this process. And there may be no change tracking on the data, of course, on when it was updated, where it came from the beginning, and so forth. No sanity checks. If one moves over to like model training in general, right, we can pick multiple algorithms to make sure those are fine-tuned with hyperparameters to get an accurate model. But all of this most likely are done locally on your own computer. You're trying different things, you see what works best. Once you kind of want to train things, if it's intense on a GPU, which a lot of things are, maybe you want to copy over your code or your scripts to a cluster of some sort. Maybe you do it manually, and then you just kick off a run and see kind of what you end up getting. But again, a lot of these things are just manual and it's very exploratory, and you're just trying to find something that works for you. And once you've found something or you've done a couple of these training rounds, you get metrics and you get performance data. And these metrics as well can tell you a lot of good stuff like accuracy, F1 score, all kind of fun things there, right? You may also get performance data if your model is fast enough to make an inference here for your application. For example, if you have video sequencing, you want to make sure it can actually predict the frame per second or whatever metric you have. But again, these metrics may just be stored if you're lucky. I mean, I've seen clients and I've seen people that are just like, okay, great, 90% accuracy, perfect, put in production. And then they forget about that metric because it doesn't really matter for them. They just hit their bar and they forget about it. So we have no idea how good something is in production. Other people may actually put them in a like Excel list somewhere and like this model has these metrics and it's great. So they have some track. But rarely is it automated or rarely is it in a very constructive, structured way. So once we have a model, we kind of throw it into some repository. You know, it could be a blob storage in Azure. It could be a bucket in AWS. It could be a local file share, wherever you want that more or less. And a lot of places, they kind of just put all responsibility on the dev team later to incorporate that model into their app through an API. Or other, of course, they can spin up a container in Kubernetes and expose the model through a web API in a container as well. But generally, you just kind of throw it over the fence. So if you look at what we noticed here, which is I try to emphasize that a little bit too much, of course. This, of course, varies lots. But generally, we are on something called maturity level 0 here. It's very manual. Everything is on my machine. It's difficult to repeat. If I want to get the same model again, it's not really clear on how I would do that. There is a clear disconnect between machine learning and like the data science teams and operations. Like there's no feedback loop from operations, of course, back into the data science team if they find things in production that are broken or if the model drifts. There's no frequent release iterations here. Usually what you will see is that you create a model, you put it in production, and then you forget about it until by some reason you want to do it again or improve it. But there's no frequency here. One of the more important things here is the lack of auditability. And as you will see, I think in next coming years here, we'll have more and more regulations from the federal government on how AI and machine learning should act and behave, and especially on explainable AI, how you can understand how a model thinks. And to do that, you need to trace all the way back to the data, right? You need to trace all the way back to the algorithm it shows and everything else, the code used for training and so forth. If you don't have that, it's very difficult for you to show like how you based your training on. And even if you can have some explainable stuff, you're still lacking that auditability, which is very important. So throughout the presentation today, I want us to kind of think about and look at stuff, how we can move from maturity level 0 here to 1 and 2, where we start automating things more, putting more in DevOps pipelines, rethinking some of the ways we work with machine learning models and data science teams, and things that are normally missed as well in a manual process that we definitely don't want to miss. And these maturity levels are taken from the Google white paper as well. So they have some kind of, I guess, distinction to them. They're not just made up by me. But the key thing to take away as well here is that building prototypes for like machine learning models is generally pretty easy. There are a lot of like auto machine learning libraries out there. You throw the data to it and then spit something out. And there's a lot of tutorials how to do it. So for a lot of standard stuff, it's not that difficult to get a model that's pretty good if you at least have some data that you can use to predict it on, right? But deploying it to production repeatedly is very, very difficult. And the reason for that is that the focus area that many people think about is the actual code to train a machine learning model. But there's so much more in a system, a machine learning system that needs to be thought of. For example, right, serving infrastructure, like how do you handle your Kubernetes clusters? Do you have enough resources for it? How do you handle your configuration data? The data part, of course, is like a huge topic that I think you cover much better. But how do you handle your data? How do you make sure your data is correct before you train your model on it? And one part as well that I definitely want to highlight as well is the monitoring part. Once it's in production, how do you make sure you monitor the behavior of your machine learning model that will drift? And we'll dive into that a bit later. But MLOps in general, the things we're trying to address here, the things we're trying to get the value of is in generally reproducibility, getting the same model again based on some conditions. Model versioning is super important, understanding what version of the model we have in production and what version we have coming out. Getting that auditability again for regulations or for regulatory affairs is important. And then, of course, thinking about how do we package our model and how do we deploy it and how do we monitor in production. So these are kind of the things that you want to take away from this presentation. If there's any time you want to address some of these things for a client or for your company, you want to look at MLOps. So how do we get there? Let's think of that a bit. Well, to start off, first thing I think we need to do is try to compare a bit how MLOps is different than DevOps when it comes to some specific criteria. And the first thing I want to highlight here is team skills. If you think about a general like a DevOps team or like whatever you want to call that, that's usually integrated in many ways into like a software engineering team. You may have a DevOps kind of enabling team, but usually a lot of those responsibilities are absorbed by software engineers because they generally have experience with automation. They have experience with production grade systems in some ways and configurations. And they kind of have been part of that community for longer than production systems has been for data science. And that's not necessarily anything bad or good with that. It's just, I think we have to realize that data scientists in many ways are more research-based, and they may or may not have exposure to production grade services at the same degree as other teams. So we have to kind of be enable that team to grow in those skills as well. The development part, of course, is more experimental. It's not as linear as we have with software engineering, where we have features and features and features, and we can easily plan like, I want a green button on this web page, and it should do this and this and this. It's very easy to write the requirements for that because it's deterministic. Data science, machine learning, of course, is not like that. You don't always know if the data is going to yield a model. So you have to experiment more, and you need to allow for a process that will allow for that. Testing, a lot more complicated, right? We have so many different facets here. We, of course, have the, the pure software part. If you call this API with this photo, do I get tomato back or not? That's one thing. But you also have things like data verification, like making sure your data that you train a model on is actually sane and accurate. You also have things like the model tests themselves, like are you getting enough accuracy on these things? Is something drifting? So how we test machine learning models is a lot more difficult. Deployments, of course, is more complex because generally they don't go by themselves. They can, but they can also be part of an application that has its own lifecycle. So how do we marry those two life cycles into one, or have some kind of separation between them? And then the final thing is production monitoring. How do we handle things like a slowly decaying model? And I have a few slides about this later, so I don't want to spend too much time right now. But think about, like a weather forecast, something simple like that, predicting weather. Let's say we train a model to predict weather based on data from the 1800s only. That model is going to be very different than a model that you may train based on data from the last century, just because of global warming, right? So the environment around us changes, which causes the model itself to change as well. So if you put the model in production, the performance is going to change and degrade over time. And you need to make sure you monitor that so you can catch those things early and retrain it before something bad happens. Okay, so can we just build a CI pipeline? We can, but we need to think about what can change. Like in a regular CI/CD pipeline for DevOps, there generally only one dimension of change, and that's the code. If you take in new code to a GitHub repo or something like that, we trigger a new build, and that build does its thing, and then we may or may not have automated deployment, but that is the only trigger, right? When we look at the machine learning model, there's so many more layers or dimensions that can change. If we have new data, because we collect new data, that can trigger a new model. If something around the model itself changes, for example, dependencies like the scikit-learn, or we decide to use a new algorithm, that can also trigger a change in the model itself. Or just stuff like configuration for your GPU cluster. Say that you add one more GPU to your cluster for inference. That may have a huge impact on how your model behaves. So you may also want to train and deploy a model based on that. So if you dive into those layers a bit more here and start with the data first, and I won't stay very long here because I think you're all aware what can change here. But one of the things that can definitely change is the schema. So we may have new or removed features as we go along, or we may change data types. We may have like a string that contains only numeric values, and suddenly that changes to an integer value or a float value. How does that affect the model? One of the more common changes is just distribution and cardinality. So take, for example, a fraud classifier for transactions. If you train your model on like 10% non-fraudulent cases and 90% 10% fraudulent and 90% non-fraudulent cases, then suddenly you have new data where it's 50-50. That model is going to behave very differently than the model you currently have in production, just because it's going to know a lot more about fraudulent data. So that's a change in distribution that you need to take height for and make sure you retrain your model for. And of course, sampling as well. If you want to predict wind speed and you only sample every day and then suddenly change to every minute, that's going to also give you more data and more information to create a better model with. If you look at the code part here, generally what happens when you need to retrain a model here is new features or business needs. So you may have a machine learning model that predicts faces out of the picture, but suddenly you also want to segment the picture. So you want to be able to say, where are my faces in the picture? And then based on those faces, you want to predict who it is on the picture. So you may have business need that change that will cause your model input schema. So for example, what features we train a model on to change, or the output schema to change. So what data do we actually want from this model to change, depending on the outcome here as well. Bug fixes is, of course, another common one as well to think about, as well as, again, configuration that I already mentioned. So I don't want to beat that dead horse too much. So the final layer of change here is the model itself. So we have to allow for this process to be experimental. We want to experiment. We want to try algorithms. We want to try different hyperparameters to be able to find a model that is suitable for us. So we need to be able to support that. And the way we can support that generally is to have a feature branch for each permutation and have an environment that supports multi-branch training, if you will. So basically, you can have multiple pipelines running in parallel with different permutations, and based on that end result, you can evaluate which one's best. But that's just one way of supporting that. But in general, you need to have a structure and process that is supportive for this. So new data can change, of course, but the last one here when it comes to the model is dependency changes. And this is an important one. For example, let's say you have scikit-learn as a dependency when you train your Python models. There's been cases, and this has actually happened in 2019, I think, where there's been a bug in scikit-learn that greatly affected classification. So when they upgraded the version of scikit-learn, there was a complete shift in like how one of the linear regression classification algorithms behaved. So if you retrain with that update, you will have a different model completely just based on that like bug fix in your dependency. So tracking your dependencies and making sure you react to updates on those dependencies is an important aspect of the MLOps flow. All right, so switching gears here, testing. What kind of testing, or how do we ensure, how do we enable and get testing into our MLOps pipelines, and what things do we need to think about when we do that? The data validation part is something I already mentioned, and I think you're kind of aware of that as well. But you need to make sure that when you train your model and stuff, you train your model on sane values. So if you have like a price column for price prediction, making sure that those are only positive values and not negative values, for example, or making sure that your car mileage in your data set is also not negative and it's in a reasonable range. Any kind of outliers like that or data skews, it's definitely going to affect the model performance. You want to make sure you catch them early and stop your pipeline if your data tests fail, because suddenly your data is not good enough. And as part of DataOps, this may already be covered in many ways, right? This is kind of where MLOps and DataOps marry. If you already have this kind of tests and transformations as part of your pipelines in DataOps, this may already be good. So we may not need to actually think about it in MLOps, but that will depend on, I think, a use case. Another thing here to think about as well is the model validation. So there's no point of continuing, like if you do like software engineering, when we add a new feature, a button, whatever, there's always going to be a case where it has to go to production because someone's asked for this new button, and goddamn, they're going to get that button, right? Blue button in production. But when it comes to like models and creating a new model, if the model is worse than the one in production, there's no one who's going to ask for it. There's no point in continuing. So you need a system to be able to grab the performance metrics of the model in production and compare it with the model you trained so far and say, it's better or it's worse. And then you can make a decision if you want to continue down your deployment pipeline. And that needs to be automated. And you may also need to include other things here like bias and fairness as metrics here as well. Just accuracy or F1 score may not be enough here. But if we kind of zoom out of this discussion a little bit here and look at all the kinds of tests we can do here, we end up in the testing triangle that is very, very common and basic, right? As software engineers, you're kind of used to seeing this. It's exploratory tests, end-to-end tests, and so forth. And we go down in the pyramid. But when we talk about MLOps, we have multiple pyramids in one here. We have everything from data test, of course, to unit test for transformations, to API test for the whole thing. But you also have things to think about like model bias and fairness and model performance. So I'm not going to kind of dwell over this too much, but testing is complicated for machine learning models, especially when we start integrating those with an API and with a service. And it's important to really take a look at every way you can test it, because if you can't automate some of these things, you also won't really be able to have that nice pipeline. You probably always want some kind of manual exploratory testing if you can, but you want to make sure you limit those to the few as possible. All right, so moving on here real quick here to the deployment phase here, to getting it in production. So we will look more about, we'll look in a bit more on how you can kind of deploy a model to a Kubernetes cluster in Docker container. But once it's actually there, or if it's embedded in API, you do need to kind of monitor the inputs and outputs and how it's doing. So we discussed that really briefly earlier as well, but things you want to look at here as well is that, let's say you created a model for product recommendations, and it's really good at recommending products based on your user preferences. But if the model doesn't know about a new product category or new product, it's never going to recommend that to the customer. Just like you have a sales assistant, right, that is recommending things to customer, If that person has never been exposed to this new product, it will not be able to recommend it. And the same thing when the model's here. So we need to be able to monitor kind of our data, but you also need to be able to monitor permutations of what's sent in here to make sure that the distribution of the inputs are similar to the distribution that we train the data on. Because otherwise, we're probably going to see a little skew here in our predictions. Fairness and bias, again, something that's up and coming a lot, and explanatory AI. Definitely look at that. There are tons of good open source tools to do this. So you don't need to invent your own kind of wheel here, but don't forget to include fairness and bias testing of your data in production. You want to make sure that once it's out in the wild and not on your just like your test data, that it's still giving you a fair and unbiased prediction on the incoming data. And the final one again is data drift, structural, semantic, or infrastructure drift. There are many ways that like your model can change. One thing is certain with the model in production, it will deteriorate. You cannot put the model in production and just let it be there forever. It's not going to work. You can put a software application in production forever, and that would probably not change as long as you can upkeep the servers. But a model needs to be looked at, and you need to have an automatic trigger to retrain your model on certain indicators. And data drift is really one important one. And if you look at some tools out there like Azure ML or SageMaker, a lot of them have a lot of support to track data drift and to retrain your models based on those indicators. Okay, so switching gears a bit here to the tools themselves here. And then I hope we have a few minutes to give a quick demo as well on one of the tools. So based on the theory here in general, there's a couple of summary points here that we want to look at when it comes to what a tool should do. I usually kind of put them into three buckets: the tracking bucket, the model registry bucket, and the model monitoring bucket. And the tracking bucket is about tracking your data, your code, your config, metrics, and results. So if I run a run for a training, I want to track things like, okay, what were my hyperparameters? What metric did I get out? Who trained this? How long did it take? And so forth. And generally, we have two concepts around this, which is called experiments and runs. An experiment is the overall like machine learning model's purpose. Maybe it's a fraud classifier for a specific thing for a company, right? That's the experiment. That's an overarching thing. And then each run underneath that is an iteration of changing something to yield a better model, changing the algorithm or whatever you want, right? That's a run. You're trying something. So once you kind of have that tracking in place, you also need a model registry. So you need somewhere to put your models. And the important thing here is they need to be versioned. And there need to be a link to the experiment and a run to your model in your registry. And that registry needs to have an ability to kind of embed your model in some way, container, if you will, and put that in production in whatever way works for you. And then the final piece is the monitoring part here. How can you monitor and check your data once it's in production? So some of the tools on the market that are most common right now, the most common one I would say is MLflow. It's the open source version that is created by Databricks, and they have multiple implementations on different cloud providers. You have an Azure Databricks solution that has MLflow on it, so you can use, and you have the same thing in AWS. But it's open source. It's part of like I think an MLOps foundation or something like that. And it's great. It definitely has a lot of good things in it and works really well most of the time. If you are willing to pay a bit more and you want a little bit more like a comfort blanket, I would definitely look at Azure Machine Learning as well as AWS SageMaker. Those are very comparable when it comes to what they support, but they're more like a cloud service that wraps around MLflow a bit more and gives you even more comfort when it comes to data drift support, deployment support, and of course they leverage the cloud infrastructure under the hood here, so you will kind of get your Kubernetes cluster spun up for you and configured properly, and like you have to think less thinking for you but paying more, I would say. And then of course if you're like really Kubernetes freak, you can go to Kubeflow. It's similar to MLflow but like very, very focused on just Kubernetes native. If your application uses that as well, good example. And for me personally, I use MLOps.net mostly because I do my machine learning models in .NET. I'm that kind of weird person. And that's a tool that we'll look at real briefly here as well. But the reason why I created that is because I wanted to use MLflow from the beginning. I really wanted to use it. But MLflow doesn't support the type of model that I have. And it's actually a bit limited as well in tracking dependencies and other things. So it wasn't encompassing enough automation in my world. So I wanted something that was a little smarter, which is why I created this tool. So I wanted to just give you an idea what it is. This is not a marketing campaign, but I want to at least show you kind of what it is here. So MLOps.net is an open source library, and you can have a look at it yourself if you like. It's on GitHub. There's a package for it. I'm sure there's very few here that are focused on .NET, so I won't give you too much of hardship here. But basically, it's a library you can bring into your application that will, you can have multiple different backing providers. So you can have AWS S3 buckets, and you can have different NoSQL databases or SQL databases that backs your information. And it also creates your own, it kind of creates a nice model repository and a version model repository, so you can deploy models to it. And it also does things like deploys to Kubernetes automatically and so forth. So it's a nice library, something I do on my spare time here. Let's see if I think I had one more slide. And I think I will go into this in a bit as well, but it's things that's currently supported. But I wanted to switch off the slides now and go more into like just kind of demos and stuff here. And before I do that, I want to kind of open up for some questions so far on what I've gone through, if you have anything. No, I went pretty fast through some things here, but I want to make sure we have time for some demos.
Yeah, I guess for one question I have, some teams normally they have probably a DevOps person that handles most of these stuff, but this seems to be quite a lot of different things. So how do you suppose teams handle like an MLOps pipeline, if you will?
Sure. So I definitely kind of advocate for cross-functional teams. So you should have, a couple of data scientists on your team, but you also need someone with that skill, like a machine learning engineer, if you will. Most of the time nowadays, I see machine learning engineers taking more of responsibility of bridging the gap between ops and data science. But I would like, I personally would have someone that has one foot in both and kind of bridge that gap a bit and owns those pipelines. I don't really like to see kind of just putting it into registry and just dumping it to ops, because there's so many things that can change in a model, like what data it expects for predictions, or what do we expect the outcome to be, and the performance. So the team really needs to own that from start to finish. I think that's important. So you may need an organizational change to make that happen, I guess.
So my question, and you just provided the perfect segue into it, is, when we think about DevOps, a large part of that, should be cultural. If your company is just looking to hire a DevOps guy to do DevOps, that's not going to work as well as really having an ops culture on your dev team, on your ML team. So the question then is, how can you actually create the culture that can do MLOps well, as opposed to just trying to find an MLOps guy to do everything?
I think that's a great question. So I'm actually, so on Monday, I'm starting at a new client, and part of that journey is going to be leading a transformation for DevOps and QA, modern QA. And they have the same struggle, right? They have very isolated siloed teams. They don't really have any DevOps right now, but they want like a DevOps person. And a thing we are going to work on here is kind of getting that enablement team, because you still need some kind of enablement team that handles infrastructure, if you will, if you're on premise, or handles your cloud's solutions in some way, saying, okay, you're allowed to do this or this. These are the security policies you have, just like the bare bones, like a platform team. But then that's the first thing, is to kind of get that kind of practice in place that kind of does those things. Then I think one of the things you want to work on there is having a grassroots experience. You need to find those champions in your organization that have read about this or learned about this and really kind of burn for this. And you need to find those and get those together to create some kind of community of practice, if you will. And from there, you need to kind of instill that culture. But it can't be a top-down approach. It needs to be a bottom-down approach in many ways. but you need support from management and your company to invest money and time in the infrastructure as well. Because if you don't, like, there's no point doing MLOps or DevOps on premise. You need either have a cloud solution for it, or you need to have servers that have these things installed to support it. That's like the enabling team's role in anyways, and then you need to grow that culture from the bottom up. Hope that answers your question.
That does. Thank you.
You're welcome. Cool. So one thing I want to show you here is a couple of things. I want to kind of go quickly over just how it looks in Azure as an example for MLflow. And then I want to show you how I would deploy a model to production with my tool, just to give you the idea. So this is like the Azure Databricks solution. And behind the service here is like MLflow. And things you will see here is things like cluster management, right? So you can create a new cluster for your Kubernetes and define how big it is and all those kind of stuff here. And those clusters you can deploy your models to for training or inference. And of course, you have a model registry here. So you can create a new model, you can register it, and you can kind of promote it to various environments that you set up here. And then eventually you will get like a list of things where they are, if they're actually serving anything, and the version of them as well. But the tracking part here is going to be kind of under the workspace here. So you see here that I have like a user, and then I have experiments. We call this an experiment. We have a review predictor. So this one, what it does more or less is just takes in the text and says it's a good review or bad review, positive, negative. Super simple. But if you have something like this and you kind of track your metrics here, you will get like a row here for each run you do with this review. And each of these can then have metrics associated with them. So you can have like an F1 score, like how.
Oh, your mic broke up.
We cannot hear you.
Let me see if I can get my snowball back. Is that working right now?
Yeah, we hear you now.
We can hear you.
Let's see if I can get my real mic back. Is that working?
Yep.
Cool. Okay. Thank you for letting me know. So in general, this is kind of how you would do it. And the way you would integrate this into your pipeline is that you would have, if you like, let's think of you're in like a Python world here. So you would have Python scripts for your tests. You would have one script for your training and one for your evaluation and one for your deployment, if you will. And all those scripts, they would use Python SDKs to call APIs that would log these things for your stuff. So everything, when you run those scripts, they would eventually end up with a new run in here with new metrics. And you would summarize everything in MLflow, and then you would manage deployments from here if you like. And you can put those scripts into like an Azure DevOps pipeline, Jenkins, TeamCity, GitHub Actions, wherever you want them. And they can run either on a schedule, they can run on triggers for new data. They can run on triggers for commit to a repo if you change the model, whatever you want. But basically everything would funnel into this MLflow product here, so you can visualize things and see it yourself. So if I would, the way I kind of solve this myself here is using my library here. And this is in .NET C#, so I don't expect you to care too much. But I want to show you guys one example here of getting into Kubernetes. So just something simple like this, Titanic data. We want to predict if someone survives or not based on this data. So the first column here is, or second one is survived. So Boolean, 0 is died, I think, and 1 is survived. And then some other data. So we have this kind of thing, and we want to train a model around that. And what we want to do here is if we go to Azure and to a Kubernetes cluster here, let's see if we get this loading again. What we want here is we have a Kubernetes cluster here. And what we want here, we want to deploy a Docker container with a web service wrapped around it that wraps around a machine learning model that you can call through Postman. And I will pull it in here. Basically saying, I'm a first class, I'm a female, and I'm 20 years old. And you should get back true or false if you survived or not. And currently I have nothing in Kubernetes, so I can kind of call this API. It's going timeout. There's nothing here that responds to this URL. But what we want to do here is like to create that. And the way I've done this in this tool here is in this way here. And I kind of obscure some of the machine learning stuff because it's in C#. It's not really important. But I want to walk you through kind of the thought process on what are some things you want to log and get. So the first thing here, of course, is creating a run or an experiment. So what we do here is we create an experiment called Titanic. So we group everything under that Titanic classifier. And we get a run by default here, which has this unique ID and is tied to experiment. And we're using a local SQLite database here as backing, so we can kind of keep track of our data and our relationships here. But you can equally as easily put it up to Azure and Cosmos DB, or to I think DynamoDB as well in AWS. So other things we do here as well is we register the model schema. And the idea here is that we say, if someone calls my model through JSON payload in a web service, I expect 4 columns, or I expect 4 properties: survived, p-class, the sex, and the age. These are the things that my schema should expect. And likewise, I also register the output schema. So what will I get back? Label, score, probability. And these, of course, they map to the input schema I have in my payload and the thing we saw before here. And that's just making sure that we register the expected behavior of this API. So when we create this web API automatically and a Docker container, it will just kind of work. Let me kick this off real quick while I talk about it, because it will take a little bit. Actually, let's think about it later. Yeah, let's do it. And other things we want to do here as well is that we want to log hyperparameters. So when we train our model here and get our kind of trained model, we want to log things like what was the algorithm used, what were the hyperparameters that we fine-tuned. And this line here just kind of sets that into our database, making sure that's stored for a run. And then things we want to do, and we can do this either in code or we can do it through UI, is to register a model, saying, okay, this model was great, let's do it. We'll put that into a register model, which will upload it to a model repository and give it a version and link it back to the data it was created for and everything else. And we can also create things like deployment targets, which is, give me a part of my Kubernetes cluster that is called test, and subset that just for my test environment, and then have something else for production. And then eventually here, what we want to do, which is the last line here, let's get there, is to deploy it to Kubernetes. So here we go. And what we want to do here is just more or less pass our model, and we want to pass our deployment targets, and then we just want it to deploy to the cluster that I have. And the reason why there's no configuration here on where to deploy it to is because I already have that up here. So I have a configuration values here that lets me know what my kube config is, that tells me which cluster to go to. And I also have some values for my container registry. So my Azure credentials to upload to container registry in Azure here. So I will not go into too much detail here, but basically what this does here is that it builds a container automatically. It automatically generates a web API for you. It automatically fetches the dependencies for my model training. It puts those in a database to make sure I know what dependencies I have and which version. And it kind of recreates everything for you and pushes it to Azure, deploys it to container, creates namespace and Kubernetes, and kind of makes everything happen in the background. So if I let that spin away here, and let's see, and just wait for it to run. So currently it's running here. What we'll see here, if we look at refresh here, is that probably in a minute or two, we should have a new namespace here for, I think it's called Test Titanic, which is going to be the subsection here of my cluster that will kind of host my pod here with the container image that we have created automatically. And then the end result here in a minute, hopefully, is that we get a URL back from the deployment that I can call, and we should be able to make a prediction live in Azure here as well. Let's see. But while I'm waiting for this to complete, does anyone have any questions on that part? I know you're not Microsoft people, maybe, so.
I guess through the code, you can kind of configure all the parts necessary that map, like the schema, the database portion, serving, everything is kind of controlled through code.
Yep. Exactly, yeah. And you can even do things like logging your data. So there's a method as well here for logging your data. And you can pass in your in-memory data, and it will log all your columns and distributions in the columns. So at least you have an idea of that. And it can also, like, this is for smaller data sets. You can do things like a hashing, so you can hash the data. But of course, that's only reasonable for smaller data loads, not for large ones. But this is an easy way, at least, to keep some track of what data you have used. But if you look now, what happened here is that we created a namespace here called Titanic test. And this one now is going to contain a pod. If I go back to my solution here, if I look at the object we got back here, we did get a deployment URL here. So if I copy this URL here, go to Postman, and go to here, change that, I should get a response back like that. True. So now we have something in Kubernetes. So of course, this isn't .NET, C#, and it's not mainstream by any means, but the process and idea is the same here for how you manage this. And you can manage this partially by your UI in MLflow for deployments, but most of the time, the tracking part, especially the tracking part, is going to be through an SDK, like I did here in C#, that calls an API, make sure you track things like metrics and stuff as well. But with that, I am 1 minute past my time. So I'd like to thank you for listening to me today, and I'm definitely available for questions if you have any.
I guess I don't really interface with like C#, so I guess that there are really a big community of C# developers using machine learning.
There is a growing community. I wouldn't say it's large. It's a growing community. It's not large by any means. The idea is the same for, like, you have like a Python thing for sure. Basically, the Azure Machine Learning has a couple of SDKs, for example, that you can use. So if you want to track things in Azure ML, basically you just pull it down in your Python code and say, okay, this is my model, or this is my accuracy, log that for me somewhere. And eventually it'll pop up